Dear grade 9 students, hope all are fine and well. Today let's move on to the new lesson, which is 1.3, real numbers and decimal expansion. So you are ready with your notebook and your pen, right? Okay, so let's start. Before moving to the beginning of the lesson, I will explain to you what are proper fractions and improper fractions. Proper fractions are those fractions with numerators less than the denominator. Example, 2 by 5, 1 by 9, 33 by 100. And see what is the decimal form of it. 0 0.4, 0 0.111. It continues, 0 0.33. All these values are less than 1 because it starts with 0. So we can conclude that proper fractions are always less than 1. Now the next one. Improper fractions. Improper fractions are fractions with numerators greater than or equal to the denominator. Most of you knows they are greater than, but some of you might miss the part they can be equal. See this example, 7 by 5, 7 is greater. 11 by 9, 11 is greater. 33 by 33, this is an improper fraction. When the numerator and denominator are same, this is also improper fraction. And see the decimal expansion, 1.4, 1.2 continue. And then the last one is 1. These are all examples of improper fractions, and we can conclude that the values of improper fractions are always greater than or equal to 1. Now let us see how to find the decimal form of a fraction. 7 by 3. Can you tell me what type of a fraction is this? Is it proper or improper? Good. It is improper fraction because numerator is larger than the denominator. And when you find the value using this division method, you have to write the denominator outside. So 3 will be outside and 7 will be inside. Always the numerator inside. Now see how many 3 can you take from 7? 3 into 2 is 6. And now you can see 7 minus 6 is 1. And then after 7 there is no digit. There are no digits. So you can put a decimal and pull it up. After the decimal you can add as many zeros as you want, one by one. So you take the first 0, bring it down. So your number now is 10. How many 3 can you take from 10? Yes, 3 into 3 is 9. Now 10 minus 9 is 1 again. Again you can add a 0 up and then take it down. So your number is 10 again. 3 into 3 is 9. Again the balance is 1. And it will continue forever. See the next example. 6 by 11. What type of a fraction is this? Good. Proper fraction. Because numerator is less than the denominator. Great. And remember, the denominator should be written outside. So 11 is out and 6 is in. But you see, can you take 11 from 6? No. So you just always try to mark the number in the quotient. You know where is the quotient? In the same position above it. For example, 6 is not enough, so you put a 0 there. And then mark a decimal here and pull it up. After the decimal, there are no digits. You can put a 0 here. So now your number is 60 because this decimal is pulled up. How many 11s can you take from 60? Good. 11 into 5 is 55. 60 minus 55 is 5. And then again add a 0. Take it down. 50. Less than 50, how many 11s are there? 4. Okay, 11 into 4 is 44. 50 minus 44 is 6, and take the new 0, bring it down. And then continue. You will get another 5 and it will be repeated. So it is not ending, it is also a repeating decimal. Let's see the next example. 1 by 9. You know this is also a proper fraction and we write number 9 outside. 1 is not enough, so you mark a 0 and then put a decimal, pull it up and keep adding zeros. First number is 10. 9 into 1 is 9. 10 minus 9 is 1 again. Take the new 0. 10. 9 into 1 is 9 again, and you know how to continue. You can see that this is also never ending, so your answer is 0.111 and continue forever. Okay. Now let us see what is the decimal form of a fraction given to you. Here there are three proper fractions. 2 by 5 will be 0.4. You can do the division as we did just before and to get the answer. Here there are no dots because the remainder is a 0. Again, 13 by 20 is 0.65. It will end there because the remainder is 0. But 6 by 11, there was no the remainder was not 0, so it is repeating 0.5454 and continue. Next one is an improper fraction, but it is an ending. The remainder is 0. And the next one is 7 by 3. It is not ending. It repeats 333 forever. So what did you notice from here? First three of them are proper fractions, and the values are all less than 1, 0 point something, again 0 point something. These are all less than 1. But look at the last two examples. They are improper fractions and their values are greater than 1, or in rare cases they can also be equal to 1. Okay, now we have to see properties related to the digits after the decimal. Now, in rational numbers, we can rewrite the fraction in the form of a decimal, and this decimal will be of two forms. Either they will end after few digits, or it will repeat with a special pattern. Okay, so look at this first example. 0.4, it is ending. We call it terminating. 0.65 is also terminating. 3.4 is also terminating. But 0.54 is a repeating number. 5454 is repeating. So this is one of the property. The decimal value will either end or it will repeat. Now the next property that you have to understand is how many digits are going to repeat. Only one digit or only two digits or more. The idea is that we look at the denominator. Look at this denominator 11. The number of digits that are repeating will never be more than 11. Maximum digits that will repeat is 10, the number just before 11. Or look at the last example, 7 by 3. The maximum number of digits it will repeat is 2, just before 3. Okay. Now, let us move on to more examples of proper fractions. We studied that rational numbers can be represented in the form of decimal in two forms. Either they will terminate, means they will end. See, look at this example, 0.4. It ended there. 0.75, it also ended there. Or it can also be decimals which will not end, but they are repeating. They are called non-terminating but recurring. Recurring means repeating. These are called rational numbers. So rational numbers are represented in two forms, or two types of decimals can be rational numbers. Either it can end or it can repeat. Now let us see how the irrational numbers will look like in the decimal form. It will not end, of course, and it will not repeat. Great. So irrational numbers will not end and will not repeat. So let us see more details about it. So you know that pi is an irrational number, and here is the picture of Archimedes. He is again a Greek mathematician who discovered the values of pi until 6 digits and more, until a few digits after the decimal to know the value of pi. And also we have a great mathematician from India. His name is Aryabhata. He also discovered the value of pi until 4 digits after the decimal. This all you can do research online and you will get the idea about it. So here there are irrational numbers. You know these are irrational numbers because not ending and not repeating. Pi, square root 2, square root 3. Not ending and not repeating. Now here there is a small research work for you if you are interested. You might wonder why we call pi is irrational, but the value we substitute 22 by 7 is a rational number because we have a numerator and denominator. Because I told you in lesson 1.2 that when you replace pi by the value 22 by 7, there is a minor error. We ignore this error so that you will get an answer for finding the area of a circle or cylinders and details like that. So you can go research why do we replace and what error are we going to face. Now let us see how to replace a repeating number in the form of a fraction. Look at this example, 0.666. It continues, not necessarily 3 sixes. You can write as many you want. But in a short form, we write it as 0.6 bar. This bar means the number under the bar is repeating. Only 6, so 6 is repeating. How do we rewrite? The first step is we write the given number as a variable, x or y. So x is equal to the given question. Now the second step is see how many numbers, how many digits are repeated. Only one, because under the bar there is only 6. So you multiply both the sides by 10. 10x is equal to, on the right side when you multiply you move the decimal one step forward. So 10x is equal to 6.666 and continue. Now we have equation 1, equation 2. Subtract equation 2 minus equation 1. So you will get 10x minus 1x is 9x, and on the right side after the decimal both of them get cancelled and 6 minus 0 is 6. So you get the answer x is equal to 6 by 9, and of course you have to simplify, which is 2 by 3. Let us see another example, 3.5727272. See, have you noticed that 5 is not repeated, 72 is repeated. So the first step is take 5 to the left side. So we replace x is equal to 3.57272. Then move 5 to the left side of the decimal, which means multiply by 10 because you are moving one step. So when you multiply 10 on both the sides, you will get 10x is equal to 35.7272. And now, how many digits are repeating here? Look at this bar. Under the bar, how many digits are there? 2 digits. So you have to multiply by 100 on both the sides. So on the left side, when you multiply 100, you will get 10 into 100,000 x, and on the right side you move 2 steps forward, so you will get 3,572.7272 and continue. Now this is your equation 1 and this is your equation 2. Subtract 2 minus 1, then you will get the answer 990x is equal to 3,537, because after the decimal those numbers get cancelled. And then the final fraction is this. Okay, now let's see more examples of irrational numbers in the decimal form. Here there are some examples. Have you noticed they are not ending and they are not repeating in a specific pattern? Let's see the exercise now. 1.3, the first question, 36 by 100. This can be done in two ways. You can do the division as we did in second slide, or you can also just move the decimal back. Because you have 100 in the denominator, just move it 2 steps back. So your answer is 0.36. You can do this step if your denominator is 10, 100,000 or 10,000 numbers like that. Just move the decimal. Now 1 by 11 you can only do it by the division method, and you can see that it is repeating. 0909 is repeating. So we studied that rational numbers can repeat, or like the first question, it can end. Next one is a mixed number. So here 4 is a whole number, so we keep 4 as it is. 1 by 8 is a fraction. Do the long division as we did, and then you will get the answer 0.125, and it will end there. So add 4 to it, you will get the answer 4.125. It is also a terminating decimal. Another example is 3 by 13. You can do it mentally, so you have to do the long division and you will get the answer here. See, have you noticed? 0.230769, again 23 is repeating. So something which repeats is rational number. And also, you know, this is with numerator and denominator with natural with integers are also rational numbers. Another example is 2 by 11, and this is repeating. 0.18 is repeating, also rational number. Another example is, you can also do the long division here, and you can see the remainder will be 0, and this is a ending or terminating decimal. Okay, now let us see what is the value of 1 by 7. When you do the long division, you will get it. And you see the bar there. What does this bar mean? All these 6 digits are repeating, which means 0.142857, again 142857, 142857. It's a never ending process. So that's why the whole bar is there. Now the question is how to find 2 by 7, 3 by 7, 4 by 7, and 5 by 7, and 6 by 7 using this number. It is very simple. From 1 by 7, when you multiply by 2, you will get 2 by 7. So to the right side, the decimal number, you just multiply by 2, you get the second number. Multiply by 3, you will get the third number, and continue till the end. So for example, if you want 6 by 7, you just multiply 0.142857 by 6, and you will get the answer. Okay, now question 3 is 0.6 to 6 bar to replace it as a in the form of p by q. So you know 0.6 can be written in the form x is equal to 0.66, and multiply 10 on both the sides. And this is already done in slide 3. You can get back and understand it. Now let us see another question, 0.47 bar. So first of all, we will replace the question by a variable x is equal to 0.4777. The first step here is to take the number 4 to the left side of the decimal point, because 4 is not repeated. So there is only one digit, so we multiply 10 on both the sides. So we have 10x is equal to 4.777. Now these two are not equal. See the first equation and second equation, they are not equal. So we multiply again by one more 10 so that the numbers will be the same. Look at this one, only 7 is repeated. So multiply 10 on both the sides. So it will be 100x and 47.77. So this is your equation 1 and this is your equation 2. We minus them. 100 minus 10 is 90x and 47 minus 4 is 43. And all the numbers after that will be cancelled. So we have x is equal to 43 by 90, and it is already simplified. Next question. Here you can see that there are 3 numbers repeated, 0.001001, continue. So we have to multiply by not 10, not 100, 1000 on both the sides. So when you move 3 steps forward, the decimal will reach just after the number 1. So 1.001. This is equation 1 and this is equation 2. We minus them. So 1000 minus 1 is 999. X is equal to 1, because 1 minus 0 is 1 only. So you'll get the answer 1 by 999. Great. Now let's move to a wonderful question number 4. 0.999. Can you guess the answer? Because this is very close to what number? Let us see. So the first step is we replace by a variable x and we multiply both the sides by 10 because only one digit is repeated. So 10x is equal to 9.99. Equation 1, equation 2. Minus them. 10 minus 1 is 9x and 9 minus 0 is 9. So x is equal to 9 divided by 9, which is equal to 1. Great. It's really amazing. Now, next question is maximum number of digits repeat. Next, we have to write 3 numbers in the decimal form, which are irrational numbers, which we already studied in lesson 2, and here pi is equal to, it's not repeating and it is not ending. Here are 3 examples. You can write as many as you want with using square roots. Another example is you are given 2 rational numbers here, 5 by 7 and 9 by 11. We have to find some irrational numbers between them. In such cases, the best thing is find the decimal value of these rational numbers using division method. So this is 5 by 7 and this is 9 by 11. So it's so easy now to find any three numbers or as many numbers you want in between 0.71 and 0.81. You can choose any number, for example 0.73, but remember it should not stop and it should not repeat. Look at this one. None of them are repeating, none of them are ending. Always remember to put dots at the end. Great. Let's move on to the last question. Classify the numbers as rational or irrational numbers. This, you are perfect with that now. Here you see root 23. Root 23 is an irrational number because 23 is not a square of any number. If it was 25, you can say 5 power 2 is 25. So this is irrational number. Another one is square root of 225. This is a rational number because 15 times 15 is 225. So it is a square number. So this is rational. This is an 0.3796 is an ending or terminating number, which is rational again. Here also it is repeating number 478. 478 is repeating or recurring. So this is rational number. Good. Now you look at the next one. It is, you'll feel like they are repeating, but no. First you have 1 0, then 2 zeros, then 3 0. There is no fixed pattern. So this is not repeating. So it is irrational number. Now that's your homework time. I want you to write these three numbers in the form of numerator and denominator. You know how to do this one. First you put x is equal to this, multiply by 10, then 100 or 1000, and then get the numerator and denominator. Also don't forget to simplify. That's all for today. Hope everything is clear. Keep practicing. Inshallah, see you soon in the next period. Bye for now.